So now let's do the next one, which is nothing but the laboratory preparation of alcohols. So now there are totally two different ways in which they can question this. The most common way is nothing but laboratory preparation of alcohol from an alkyl halide. So you know how to write a formula of an alkyl halide by now. So there will be C2H5 and then you will be having a respective halide. It can be Br, Cl, it can be anything. So you will have Br. And now next is supposed to be your alkali. So now the alkali that you generally choose, which should be cold or dilute. It should be cold or dilute. So it should be KOH. So it can be cold and then dilute, because when you have an alkyl halide and when you have hot and concentrated, you will be getting an alkene and then you will be getting a subsequent minor products. But then in the case of C2H5Br and then KOH, in case if you use a cold and dilute form, you will be getting an alcohol. So this on treating, you will be getting C2H5OH. On carrying on this reaction, while making use of cold dilute KOH and the alkyl halide, you will be getting C2H5 and then this OH here, which is the hydroxyl group, and then this Br is left in this compound and the potassium is left in this compound. So you will be writing plus KBr. This is the most simple way in which they can question you, which is nothing but laboratory preparation. In case if they introduce a slight twist, which is very common in the questions, so that will be petroleum to alcohol. So there is a statement which says on cracking of petroleum. So now you have petroleum and then on cracking, when you crack petroleum, you will be getting ethane. So you will be getting ethane on cracking petroleum, because petroleum is supposed to be a very good source of all forms of alkanes. Since it's a very good source of all forms of alkanes, so on cracking of petroleum you will be getting ethane. That is step number 1. So step number 2 is getting an alkyl halide from ethane, and we know this is nothing but basic or general halogenation of alkanes. We have studied in the chemical properties of alkanes. So next is nothing but for example, if you assume that we are getting ethane, so the formula will be CH3 single bond CH3. When you have CH3 single bond CH3, you will be having bromine, and then you also know the conditions. It is supposed to be 600 Kelvin, and then apart from 600 Kelvin, you can also have HNu. HNu is nothing but basic sunlight. So 600 Kelvin or basic amount of sunlight. So CH3 single bond CH3 plus Br2 or any halogen, and the condition is 600 Kelvin and then HNu. So I am just repeating the fact for you. So it will be C2H5Br. So right now you just need your major product. So C2H5Br. So we have obtained the same thing that is there in the beginning itself. So C2H5Br, again you have to repeat the same step. So you should write KOH, which is supposed to be dilute, and then you will be getting the same products, which is supposed to be C2H5OH and then KBr. So I'll just repeat it for you. They can ask you in two ways. First way is directly give you the alkyl halide, then you will make use of cold dilute KOH, and then you will be getting C2H5OH and then KBr. Or they can give you from petroleum to alcohol. So from petroleum to alcohol, you will first do cracking of petroleum, get ethane, and then do halogenation. The conditions will be 600 Kelvin or HNu. You will be getting an alkyl halide, and then apart from that, you have to add the dilute KOH. So you will be getting C2H5OH.